Hello everyone, my name is Oscar Irigoyen and I'm very glad today with this first video showing some results of the TELOIP POC in joint solution with Infovista. So we call this solution SD-WAN 10 or SD-WAN X because we put together layer 3 capabilities of TELOIP including IPsec tunneling, link failover, bandwidth aggregation over the internet, and its orchestration with the Infovista application performance technology given intelligence up to layer 7 to the SD-WAN technology. So DPI for application visibility and dynamic quality of service to prevent congestion, to prevent user experience degradation. So layer 3 plus layer 7, the SD-WAN 10. So in these two videos, we are going to see first the context of the setup, what are the elements that were put together for doing the POC, and some consideration for the configuration of the boxes. So very important to understand the mechanics of the solution. And in the second video, we are going to see some results about application visibility, dynamic quality of service, failover, and bandwidth aggregation when we have congestion in the network, and how we can guarantee user experience for mission critical applications over the SD-WAN. Let us start with the setup on the testbed. So we have essentially two sites, Atlanta and Dallas. In Atlanta, we have a PC connected via a 4AX Infovista box that is going to give the layer 7 capabilities, and TELOIP box, which is going to give the layer 3 capabilities. So, and they are chained physically and connected to the internet via a modem, ADSL. On the Dallas side, we have also a PC, the same configuration for the Infovista and the TELOIP box, but this time we have two links, so to test failover and bandwidth aggregation. The TELOIP boxes are controlled from the TELOIP POP, while the Ipanema, the Infovista boxes are controlled, monitored from the Infovista cloud controller, which is called SALSA. So for doing that, we need to pre-configure the boxes with a private IP address and a gateway, which is essentially the TELOIP box, and give the URL of the Infovista controller and the TELOIP domain created in the Infovista SALSA platform to the boxes, and in this way, getting reachability through the internet, we can connect the boxes to the controller SALSA. First thing to configure the system is getting the correct values of throughput on the links, because you know the internet is very variable in terms of its capacity from 1 hour to another, from one day to another day. We can have differences on the throughput obtained. So for instance, let us start testing my bandwidth just right now from Dallas. I am in Dallas and I am using the PC on the diagram that I showed just on the left. So in this side I have, as I mentioned, two links. So this bandwidth, about 46 megabits per second, is the addition of two links already encrypted and going to the TELOIP pop, and we have about 44 megabits per second for the upload. So yesterday I had those figures, so less in the upload, much less. So again, internet is best effort. If I do the same test right now for Atlanta, so let me use my RDP connection over here. So exactly the same test using the TELOIP portal. Very nice tool for bandwidth testing. So we will have about 120 megabits per second download in Atlanta, a single link, and a huge bandwidth for download. But on the other hand, we have a kind of weak upload. So about 12, 11 megabits per second an upload. So I had these values yesterday. So this is very asymmetric, and so here we have our bottleneck, right? So this is very important to understand. Then this is our bottleneck, and here we need, above all here, but everywhere also, to have the control activated to prevent congestion. So given those figures, I use my rule of 70%. So I'm going to remove 30% of uncertainty of the links, and having these new values. So instead of 47, 33 or so, 28, 19. So I just multiplied those initial values or measured values by 0.7. Same thing for Atlanta. And finally, I normalize them, I round them, and I have these two capacity values, 32, 19, and 85.7 megabits per second. Those are my baselines, extremely important. With those baselines, I'm going to decide when I'm going to trigger control. So when I reach the congestion, those are my trigger points for detecting congestion, and also for controlling, for creating traffic and avoiding that we destroy flows when we get this baseline. So it's my one of my most important baselines of performance. So with this information, I can right now create on the SALSA platform. I have my SALSA platform over here. I can create the interfaces of one axis. The SALSA platform has three sections: configuration, dashboard, and reporting. Configuration is the section that I'm going to use most. Dashboards as well, and dashboard has the real-time metrology and visibility. Reporting is historical information. So first thing is to show and see, verify that my services, specifically of visibility, is activated for my first configuration. So and as I said, I need to create a one axis, because this is a very specific bandwidth for the first site, which is Dallas, and the second Atlanta. And I need to define those specific thresholds. So Dallas was 32 and 19 megabits per second, so I already created this, and I have here 32 download, 19 upload, and the minimum, which is another uncertainty percentage, which is 10%. I'm using 10% of protection additional for my minimal bandwidth, so 17 megabits in this case and 29 in this case. Same thing for Atlanta, which is 85.7. So again, I have 85 and 7 and the minimum, which is 10% less. So with this one access, I can configure my appliances. And over here I have Dallas, for example, and I'm going to see what are the main parameters I need to configure. I'm going to do a kind of zoom, and again to see the whole configuration window for Dallas. So is Dallas, Normandy is the street, and so here I have some parameters that are not mandatory, which is very important. Well, is the site name, the name of the appliance. In this case, I didn't use a name, so the system associates the IP address, and this IP address is the private IP address. As I said, the appliance already have the URL of SALSA and the domain name. This is the URL of SALSA and the domain name is over here. So with this information, the appliance is capable to connect to SALSA, and so I need the IP private address only for differentiating this appliance to a secondary appliance for high availability, for example, in the same LAN. I have auto reporting as a default, and reverse it is because we have the appliances over the internet, everything is over the internet, so reverse mode is important. Normally, if I have SALSA on premises, reverse is not needed, but in this case it is an internet connection. So WAN selection, I have a single link in both cases connected between the Infovista box and the TELOIP box. And here we have this parameter, which is the WAN access speed, the one that we create before, or we need to create previously, and the list of WAN access. So we need also application control activated and the status of the appliance enabled. Will be the same for Atlanta. Name of the appliance, private IP address, auto reporting, reversed for internet, the speed of the WAN access connection. So if I had two links, which is not the case of our value proposition here, I should have another WAN access or a third WAN access. So control and enable. Last element to configure in SALSA when you add an appliance is the time synchronization. All the appliances require a common source of timing because they share timestamps for doing metrology in terms of timing, in terms of correlation of packet losses and throughput and other metrics. So just make sure that your appliances are on the right side. Here we have the NTP server, and the two appliances can be also references, secondary references, and here we have the directory of appliances. So just make sure they are on the right side. And so that's it. I have already configured the appliances, and I can see the dashboard and specifically the sites that are represented for the appliances. So here we have our bottleneck 7 megabits and 80 megabits per second for the, this is the upload, this is the download. Right now we don't have congestion, And here we have the Dallas Normandy uh, appliance. We have internet and out of domain internet. Of course, it's all the traffic that is going or coming from internet, and the out of domain is all the traffic that is not classified and that is not defined in our system. Okay, so let us right now, let me see, in my presentation we already did all that. Let us see how the system behaves if we add some flows in Atlanta. I said we are going to focus in Atlanta because it has this bottleneck. So Atlanta is over here, and let us start activating YouTube video over here, and also I'm going to reactivate a VLC video that I am just transmitting. I am streaming from Dallas to Atlanta. That's it. So it's arriving. So right now we don't have any congestion. So user experience is good. It's very nice. The images are fluid, are good quality, and I can see also how the traffic is being uploading from Atlanta. What is happening is that this is Atlanta, so my RDP connection, and on Atlanta I'm just downloading this video from YouTube and also receiving this VLC, and I am retransmitting via RDP all that to Dallas. So of course we have some latency from Dallas to Atlanta. So let us back to our system. So essentially I have the evolution of my priorities of traffic, top to high, medium, and low. So it is changing in the time. I don't have control activated again. We have also my top applications in terms of AQS. So RDP is just converging. When you have a value like this, very low, it has two meanings. First is that really the application is behaving bad because it has certain period of time behaving bad, or it is because we have new flows that are arriving, and you require certain time to have a correct convergence for the SLAs, for the application quality scores. We have also over here the distribution of my traffic. So YouTube in Atlanta on the download side is the most prominent. In the upload is the RDP. We have also the traffic of the connections coming or going to Atlanta. So Dallas is the most important site. Internet has also certain traffic, and here in the download side, internet has more traffic because the YouTube flow. And here we have the triple evolution in terms of criticalities. So top criticality in my case represents RDP, for example. Low can represent internet. So this is for the upload. So we have here 8 megabits per second. So if you remember, our interface is about 7 megabits per second, and we have here the download about 85 megabits per second. So we have some spikes. And this graph shows the evolution of traffic per applications. So over here we have some internet in red, some RDP on previous tests. This is my upload, so maximum 8 megabits. If I see my download, I have above all spikes of internet. We have also flows, uh, and the flows with all the metrics, a very detailed view of the flows for the different applications with its criticality and throughput and other latency and packet loss metrics. So you can see here that Atlanta is using about 66% of its capacity on the upload, probably a little more. It will be updated. So we have VLC over here and YouTube, and we have that most of the traffic is being updated as with an AQS of 10. So very good. We are going to show some reports also. The reports are important for doing some troubleshooting, for verifying that things are okay. I'm going again to use Atlanta. For instance, let us see the hour, the latest hour, and we have PM performance metrics. We have also application metrics, especially for TCP and um, other type of reports. So let us see the detail per application group. And here we have the evolution, but in the latest hour in this report. So again, we have, for instance, over here, RDP, we have internet. This is the download, this is the upload of Atlanta. We have other types of reports. It's important when if we want to see the historical information. So let us see, for example, the time evolution, performance time evolution in the latest hour as well. And here we have LAN to WAN, meaning upload, WAN to LAN download. So we have certain throughput, so the throughput up to 8 megabits per second or so. Here with some spikes close to 30 megabits per second. It can have more. We have also packet loss. In this case, this is our bottleneck, if you remember. So we have coincidentally a lot of packet loss, or more packet loss than in the other part of the interface, meaning in the download, and probably it is because we have here the bottleneck. So we have the same throughput that we saw before on the LAN and the one for a download, for upload and download. We have good put and throughput, and we have also the number of sessions. So about 25 sessions over here. Let us see how the system evolved. So yeah, so right now we have more statistical robustness. So it is about 90% of the interface in the upload side is being used, and we have YouTube, VLC, RDP that are more of them in AQS of 10, and it is because we don't have here any kind of congestion. We have some space, and that's working correctly. Okay, so this is the end of our first video. I'm very happy to present the second part of this POC results. Thank you very much. Bye.